So this is problem 3, practical kinematics 2. So there are two cars. Car B is traveling along the curved road with the speed of 50 meters per second, while decreasing speed of 2 meters per second square. So as you can see when they show in graphic here, 50 meters per second. Let's look at the graph, go down, and 2 meters per second go up because it decreasing, deaccelerate. So it opposite to the direction of motion. At the same instant, car C traveling along the straight road, so with rectilinear motion, at speed of 30 meters per second, and also deaccelerating 3 meters per second square. So as you can see, acceleration on the finger 3 meters per second square right there, opposite to the motion, which is the velocity 30 meters per second going down, acceleration going up. Determine the velocity and acceleration. So two parts in here of car B relative to car A. So relative motion and two components, acceleration, velocity and acceleration. So let's start with always with the velocity first. So that B relative to C. So you have B vector velocity equal to velocity vector of car C plus VB relative to C. And we use scalar equation with components x and y. So draw the kinematic diagrams. So you have VB on the path, and as you can see 50 meters per second square going down. So you have that here, VB going down and equal to 15 meter per second, not second square, because this is velocity, equal to VC. VC going down vertically. So you have VC, and in this case, VC equal to 30 meter per second. And then VB relative to C, we don't know, so we can have x component and y components. So this basically VB relative to C, y, and VB relative to C, x. And we assume xy components, xy positive direction as usual. So what is the angles of the VB? Here, if you look at the problem, the finger, let you pick here. So you have 30 degree in here. So if I make a straight line in there, that will be 30 degrees. So the angle from the VB, velocity B, and the horizontal, it will be because it's tangent to the path, that a right angle, 30 degree there. So it have to be 60 degree there. So from that, we have that angle is 60 degree. So from that, we can x and y components, and now we can do fast with this, as you are familiar with the first two problem. So it will be 15 cosine 60 degree equal to vertical, so 2x is 0, plus VB relative to C, x. And from that, I have VB relative to C in x components equal to 7.5 meter per second, and it's positive, so it go right. All right. And then we have y components, and now I expect you familiar with scalar equation now after we have gone through two problems already. And we have it 15 sine 60 degree negative, because it's going down, we assume going up positive, equal to vertical going down, so it will be negative 30. And y components, so we have plus VB relative to C in y. And from that, I can have one equation, one unknowns. So I can have VB relative to C in y components equal to from the calculation, you can have 17.0 meter per second, and it's positive again, so it will be same as our assumed direction going up. And because velocity is a vector again, so we have to solve what is the direction, what is the magnitude. So let's draw the diagram again. 7.5 positive, so it will be go to the right. That's the x component, 7.5 meter per second. 17 go up, 17 meter per second. So the resistance, which is V, will be on the diagonal. So that is the V velocity of B relative to Kc. And the angle here is theta. So we want to find the magnitude and the direction. So we have VB relative to C magnitude equal to square root of those two, 17 square plus 7.5 square, and from that we get this one is 18.6 meter per second square. That is the magnitude of Kb relative to Kc. And then we also have angle theta, so inverse tension. So we have angle theta equal to inverse tension of opposite, which is 17, adjacent 7.5, equal to, with that we have the angle is 66.2 degrees. So with the velocity we have magnitude and we have the angle, so we can say the velocity answer, velocity of Kb relative to Kc equal to 18.660 meter per second at 66.2 degree, and in this case counter clockwise from positive x-axis. And in the next, and that is the answer for the first component, relative velocity of Kb relative to Kc. In the next solution, in the next video, you will see the solution of this same problem, but to find out the relative acceleration of Kb relative to Kc.